Welcome to Decoding the Data Ecosystem, a podcast with valuable insights, inspiring stories, and practical advice to guide you on your journey through the world of omics research and how the NIH Common Fund data ecosystem can support that journey. I'm your host, Dr. Allissa Dillman, and I'm the Training and Engagement Director of the CFDE Training Center. My background's in bioinformatics, and I've been working in bioinformatics and data science training and engagement space for almost the past 15 years. I'm really passionate about lowering the barriers of entry for these fields through creative engagement activities such as these podcasts. Now let's get to the show.
All right, hello everyone. We're here with Dr. Margaret Taub, who is a senior scientist in the Department of Biostatistics at the Johns Hopkins Bloomberg School of Public Health. She collaborates with clinicians and epidemiologists to analyze genetics and genomics data to understand the causes of complex diseases. So hello, Margaret.
Hi, it's great to be here.
Why don't you tell us a little more about your background and how you became interested in genomics and statistical genetics?
Yeah, so I guess I have a relatively long path to where I am now. As an undergraduate, I studied mathematics. So really pretty abstract stuff was sort of my favorite courses that I took. I had very little exposure to health or biological sciences in my undergrad, even though I actually had loved biology in high school and wanted to take some biology classes, but then got intimidated by the pre-med culture and didn't want to be taking classes that were so intense. So I studied math, and I did spend some time one summer doing math research, but that was enough to convince me, while it was a great program and I had a great summer, that graduate school in math wasn't going to be a thing that I wanted to pursue. So after I finished my undergrad, I was lucky enough to teach high school math for a year, and then I went to work for a company that was a consulting company that helped different different companies understand consumer behaviors in their markets using statistical methods. So this company would design consumer research surveys and collect data and then build predictive models using this data to understand how customers made choices in different markets. And so this was actually my first exposure to statistics. So learning a little bit about how we collect data and can make decisions or predictions based on the data that we've collected. And so that was interesting to me for sure. But after a couple of years, I just was feeling like, well, I'm not really feeling super motivated by helping other big companies make more money. I mean, to me, that wasn't something that was just getting me out of bed every day. And so I thought a little bit about a career change and was reflecting on different career paths that I found inspirational. And I have an aunt who is an MD, but did a lot of clinical research. And it made me think about medical research as a potential area that I'd be interested in getting involved. And I guess that at that point, I felt like I wasn't really going to go back to med school and become a doctor. So I had a friend who had studied statistics as an undergrad, and I started thinking about statistical genetics as an area that was interesting to me. It seemed to combine sort of my math skills with important biological questions. So statistical genetics is actually an old field, has been around for a long time. It's something that there was a lot of literature and history around, and I felt like, oh, this is something that I feel could combine my background with an area that I'm interested in learning more about. And that's sort of how I ended up studying statistics. I knew from the beginning I wanted to work on applications in biology. And then I really ended up getting extremely lucky when I entered the field. So I started grad school in around 2003. So at that time, it was the beginning of an explosion in new technologies for collecting biological measurements. So at that time, microarrays were still a big thing. The new SNP chips were coming out with 10,000, then 100,000, then a million different variants on them. And so there's just an explosion in genome-wide association studies. And then right around the same time, the new high-throughput sequencing technologies were also being developed. So RNA-seq was just coming on as a potential technology for people to be collecting gene expression data in a more comprehensive way than we could do with microarrays. And so all of these new technologies open new statistical questions as well as new research directions that people could pursue with the types of data that were being collected. And so I really was lucky to be well positioned working with someone who had been a leader in statistical genomics before he got his hands on early data. And I really was able to establish, build knowledge about analyzing data from these types of technologies and start collaborating on projects to help people answer their biological questions using the data from these types of technologies. So yeah, that was a long answer, but that's how I ended up where I am now. And I guess at the end of my PhD, I did a postdoc because I wasn't sure what I wanted to do, if I wanted to become a tenure track faculty somewhere. I knew in the long term I wanted to be able to stay in academia and do teaching, but I wasn't sure if grant writing was really the thing that was going to be the thing I wanted to like rest my whole career on. So I was really lucky through my postdoc to have experiences building long-term collaborative relationships. So when I was able to join the faculty here in a non-tenure track role, my job is really to collaborate with other researchers to support their work, to do the statistical analyses, guide the statistical analyses of that work, and I also get to teach a fair amount as well, which is something that I really enjoy.
So, part of the reason why we asked you on the podcast today is because we also know that at your current role at Johns Hopkins, you're involved in a program called Acute to Chronic Pain Signatures, or A2CPS. So, we'd love to hear a little bit more about your role in that program.
Yeah, so I guess it was back in early 2021 where HUCPS had been happening for a little while already. I got a message from my colleague Martin Lindquist, who is one of the PIs on the grant that's funding the HUCPS work. And he reached out to me because they needed someone to come on board to help oversee the next phases of the data collection and generation for all of the omics data that was going to be generated as part of this project. So as someone in the department here at Hopkins who had a long-term background working with this type of data, and working on collaborative projects specifically around analyzing genomics data, I think Martin thought I would be a good fit for it, and I was really excited to come on board for the project. And I think it was a great opportunity for me for growth. Some of the different omics technologies were data I hadn't worked much with before. So there's a couple different types of protein measurements. There's metabolomics and lipidomics data, extracellular RNA. So those were all types of genomics data that I hadn't really worked with before. And then, of course, genetic variant data as well. So really, it was a combination of new things for me and existing technologies I'd worked with. So yeah, I was really excited to get involved in the project.
So, for those of our listeners who are new, can you give us maybe just like a very brief overview of the A2CPS program and kind of what its goals are?
Yeah, so the main goal of A2CPS is to develop a predictive biomarker to distinguish patients who are going to progress to having chronic pain after an acute pain event from patients who don't develop chronic pain after an acute pain event. So it's a clinical study. The data collection is still ongoing, although it's very close to being wrapped up now, where we are enrolling patients who are about to undergo a surgical intervention. So we have two arms. One of them is for thoracic surgery, and the other one is for knee surgery. And we enroll the patients prior to their surgical event. We collect baseline data on them before the surgery, and then we follow them for their final required or expected participation is 6 months after their surgery has taken place. And during that time, we collect multifaceted measurements from them, including psychosocial, functional data, brain imaging data, and genomic data, among other things, to really create a multifaceted portrait of who these individuals are, what their experiences are on their recovery trajectory after the surgery, in terms of what their experience of pain is after the surgical intervention. So yeah, the goal is then to take all these different data types and create a predictive model that can distinguish people whose pain resolves after the surgery from people whose pain persists and who develop chronic pain after the surgery.
So part of this work, if I understand correctly, is about finding biomarkers for that transition from acute to chronic pain. Like, what's so important about finding these biomarkers, or what's sort of like downstream of, okay, we have these signatures, now what?
Yeah, so there are a couple of different things there that are important. So on the one hand, just understanding more about the biological mechanisms that contribute to development of chronic pain is important on its own. By understanding more about the biology, we can really understand what pathways and phenotypes are contributing to or causing the pain that the people are experiencing. That gives us treatment targets, and might allow us to develop new interventions for pain management. The second really important thing is to help understand how knowing whether someone may progress to having chronic pain can influence our treatment decisions for that person. So this is really getting at the idea of personalized medicine for people who are going to have need for pain management in the short term. So it can inform clinical decisions around how to talk to the patients about their pain, how to prescribe the correct level of intervention for the patients, to meet the needs that they're going to have, make sure that they're comfortable but not exceed the amount of pain assistance that's given to the patient. So part of the motivation for this work did come out of the opioid crisis. It's the idea that we want to treat pain as it's going to be and manage it as the patients are experiencing it, and not overtreat things as much as possible as well. So it's really finding a targeted treatment for each person. And so knowing ahead of time prior to the surgery what's likely to be the trajectory for this patient can help the patient be aware of what could happen, can help the clinicians be aware of what could happen, and really to plan for and adjust to that particular trajectory ahead of time.
Okay. And just for clarification, in this setup for the acute pain, it's the surgical procedure and then the potential pain. And for clarification, is that, I imagine that's different though than like particular diseases of like chronic pain, or is there going to be potentially overlap there, hopefully?
Yeah, so I think that the idea is that we believe biologically that some of the factors that contribute to chronic pain after an acute event are going to be the same things that contribute to chronic pain outside of that context of an acute pain event. So if we just understand more about, the complex aspects that go into pain, from psychosocial to physical to immune, all of the different things that happen in our body that might contribute to developing chronic pain, that can also inform pain in other contexts outside of sort of the specific setting of this study.
Okay. And is there anything about A2CPS and the program that kind of is really unique or differs from past efforts to try to address chronic pain?
Yeah, so I think that the design of the study with these harmonized protocols across multiple different domains with omics, imaging, quantitative sensory testing, patient-reported outcomes. So really, we have all of these different elements that we're collecting data on. That's something that's new. Prior studies typically had smaller sample sizes and were more single domain than what we have here. And of course, as an NIH-funded study, we're committed to sharing the data and making all of our findings reproducible and accessible to anyone who might find this data useful. So I think that's another thing. So yeah, so it's the big sample size also compared to other similar studies. And yeah, this comprehensive and coordinated nature of the data that we're really doing all of these things at the same time points that we can really look at all of these different data types in the same person at the same moment in their trajectory. I think that that's really something that's going to be powerful here. So not only for the questions that we're trying to answer with the study, but anything that we have phenotyped in these patients that people are curious about is something that this data set is going to be useful for looking at.
So you've mentioned a couple of times now that there's quite a lot of, different data modalities and it's across different places and collection centers and things like that. So how do you coordinate and design like omics data collection or just, I guess, data collection in general within this program to really ensure like consistency and scientific rigor across all of these like sites and data types?
Yeah, I mean, I first want to give a huge shout out to the PIs and the folks that really established this study even before I came on board. I think the level of coordination, communication, and collaboration on this project has really been phenomenal. And I think everyone is really coming at it with the attitude of doing team science. And you don't feel like there's anyone who is like the dominant person who's trying to claim stake a claim about the data or the results or anything like that. It really feels like we're all in this together, and there's a lot of willingness then to coordinate and really make sure we're doing our best to create the best data set that we can in the end that will be useful to everyone. So I think that, but some of the challenges, of course, the communication is huge. We have regular meetings, both as a whole consortium. We have a monthly operations meeting where any big issues are brought up together so everyone can be aware of things and challenges that are being faced so we can come to a joint resolution of those things. On the omics side specifically, I have every 2 weeks a call that I run where we have representatives from all of the different omics data generating centers and also from the DIRC, which is what I'm part of, the Data Integration Center. So we really have people that meet regularly so that if anything comes up or if there are any concerns or questions, we can address them right away. Again, though, the folks who designed the study did a great job of really putting together this comprehensive timeline. The RAs are really well trained. The Clinical Coordinating Center at University of Iowa has done a great job of just making sure all the clinical stuff is done really with the utmost care. So honestly, everyone who's been involved in the project has just been really dedicated to creating high quality data that is going to be really useful at the end of the study.
And if I remember correctly, you're sort of the omics point person for the Data Integration and Resource Center, the DIRC. What does that actually look like? Like, what is your role on kind of a day-to-day basis dealing with managing all of that?
Yeah, so it's to me really fun. It can range from a lot of very low level things. So all the way from worrying about packages that are being shipped frozen, that are shipping frozen samples across the country. I've been on the phone with FedEx multiple times to make sure things get delivered on time. But all the way through to then designing the run list. So working with each of the different sites generating the omics data to understand their protocols, to understand their data generation design. So I can know how to group the samples in a way that will be both coordinated across all of the sites, but also work optimally for each site individually. And then all the way through to developing new methods of normalization for some of the proteomics data that, hadn't been generated at this level before, where we have, every few months, I send them a new set of samples to generate data on. So it's not all happening at once. So we have issues with technical variation across time and things like that that have to be attacked from a statistical point of view. So we really have everything from the very basics of the tracking of the individual blood tubes all the way through to creating a usable data set for the researchers at the end of the data generation. So again, this is the kind of thing I feel like I have had training for throughout my career, but it's been really fun to put all these things together on one study.
That sounds like a lot to manage. And you mentioned sort of like, needing to track all of these different specimens and things like that. How did you actually manage that? Are there tools that you use to help with making sure like all these different data types coming from different people are sort of like all in one place?
Yeah, so that's been something that the study again has done a really good job with. Of course, we're using REDCap for all of the sort of clinical data tracking. The patients are interacting with forms on REDCap to collect their data. And then we, through collaboration with folks at the Texas Advanced Computing Center, or TAC, they developed a tool that we call the Virtual Biospecimen Repository. And it is a tracking tool that is at the level of every single tube of blood that's gotten collected for the study is barcoded and tracked individually. And so that means that at any time I know where each tube is. So for each patient visit, we collect 10 tubes of blood. And then those all get sent to San Diego. But then after that, they get dispersed to all the different sites that are generating the omics data. But so for me, I know that, I have the ID and a barcode for each tube. I know where it is. And that's going to allow us then to link all of the generated omics data back to the patient level data, link it back to REDCap, link it back to the clinical data that we have. So everything is really tracked and coordinated in this way that is going to allow the data set to be well connected, so that people can easily integrate different data types at the end. And yeah, so that's been a great tool that TAC has developed for this study. It's been really important in managing all of the flow of the samples around the country, and tracking of the omics data.
So that sounds like a really cool and useful tool. This virtual specimen tracker. Is this something that is openly available, or is it something you plan on kind of making open in the future for other folks who might also be juggling these sorts of projects?
Yeah, so we do have a plan to create a publication to describe and document the VBR. And I do believe that the goal is to make it available for other researchers to use in the future. If not this specific code, I don't know exactly what the plans are on that. I think that at least having described and documented what we did and how we used it, I think will be helpful to researchers in the future, no matter what.
Awesome. So it's almost like a sort of secondary resource that'll be hopefully available. So that's really cool.
Yes.
Out of curiosity, do you do any of the sort of like normalization and pre-processing methods, or are you sort of more downstream on just the statistics side of things?
Yeah, so definitely I'm involved also in the normalization and pre-processing side of things. It ranges on the different omics data types. Each site generating the data have sort of different approaches. So some of the sites have their own in-house statisticians or bioinformaticians who run their own relevant normalization pipelines. But one of the things that's been great about the project too, we do have a separate biostatistics working group in addition to our omics and our DIRC group. And we've had the folks from each of the different ODGCs come and present their normalization methods on the biostat working group calls so we can hear and get feedback on those. For some of the different technologies, though, there weren't really pre-existing normalization methods. And so then I, along in collaboration with one of my colleagues here at Hopkins and a trainee that we were working with, have developed a new method for normalizing that data. So I was part of that process of developing that method as well. So yeah, so there's going to be methods papers that come out of this work as well. And that's true actually for all the different data types from HCPS. It's not just the omics data. There are new methods that are being developed for analyzing the survey response data with zero and like new methods for dealing with zero inflated data, or new methods for working with the brain imaging data. So really, this is the kind of project where the data types, really motivate the discovery of new statistical approaches too. And I think that's going to be the case for when we're developing the biomarkers too. How do we really integrate data across all of these different collection modalities? I think these are statistical questions that we don't necessarily have the answers to yet either. But I think one of the things that I feel, on the being an applied statistician, I think that, and in a Department of Biostatistics, we really do let the science lead the way in terms of our methods development. And I think we really love being deeply embedded in the particular type of data and the particular technologies, because it's important to understand all the details of that to really develop an appropriate statistical method for normalization or analysis of the data. So I think that's been one of the fun things about this project too, that these collaborations really need the expertise all the way from the people who are handling the blood samples and generating the data, running the machines to generate the omics measurements, all the way through to the people who are developing the new statistical methods. And they really all have to work closely together.
So for you, what do you feel like the biggest challenge is in like harmonizing all of this data from such diverse sources and across multiple sites?
Yeah, I mean, I think that, I guess maybe especially now as we're coming toward the end of the study, it feels like we really have to pull everything together, make sure we're all coordinated and on track to get all of the data generated before the funding ends at the end of the project. And I think, overall, folks have been amazing about really staying on top of their data generation. It's helped. I think that we have these calls every couple of weeks. I'm always checking in. I'm always making sure that any questions that come up from the sites as they are generating the data, that I answer them as fast as I can, just to make sure that everything is continuing to move forward. I think that, in the very beginning, there was just a large cast of characters for me to learn how to work with. But overall, again, everyone has just been amazingly dedicated. I think the NIH did an amazing job in selecting the sites to generate the data. They really, at first, when I first came on the project, I was like, oh my gosh, why did they pick 5 different sites to generate all the different types of data instead of like going to one core facility that could do multiple types? But really, in the end, I think it's been a great blessing that we have so many experts. Each of them are experts in their own type of data, but they also are great voices to have whenever we have a collective issue or something that can do with input from additional leaders in genomic data generation and analysis. So we really have some amazing people on the calls whenever anything comes up. So I think like figuring out how to leverage that expertise while also, recognizing these labs, these groups all have multiple competing demands on their time. And, I think it's been really rewarding, though, to see how careful and dedicated everyone really has been to generating high quality data for this project.
So that kind of makes me think more about, so I was asking about the data originally, but that makes me start to think more about like people. And I'm curious to hear more about like, how do you manage coordinating all these different people with very different expertise? Like, is there any tips or tricks that you really found that works with kind of navigating these, as you said, like very interdisciplinary teams kind of spread out across, literal physical space, but also like their expertise?
Um, That's a really good question. I feel like it's something that I have found different and challenging about this project for sure. I think I'm more used to being one of the more mid-level people where I have, PIs that I'm working with that are kind of doing that coordination. And in this case, it was really on me a lot of times to try to do this. I think um, part of it is that I think that have been fortunate enough in my career to have a lot of great mentors who have shown me how to not make it about me. So, it's not like I'm not here for my own personal gain or my own, I don't know. For me, it's all about what can I do to help bring out the best in all the other people that I'm working with. And I don't feel like I have a personal agenda about things have to go a certain way. I really just want to hear from everyone and, do the best to find a collective decision. And I think that's worked well on this project because people have come at things with really good faith overall. Maybe if we had had more challenging folks that I had to really be like, no, you really can't do that, I would have struggled more with that. I feel like I haven't really had to be a bad guy. I really have to be more of a support and a cheerleader in a lot of ways on this project because I think there's just a lot of willingness to dedicate time and resources to this project. I just need to help coordinate and make that happen. So in that sense, I feel like I've been really lucky. I'm definitely not the best at putting my foot down and being a bad guy in general. So I think, it's been a learning experience, though. I feel, I am more well prepared in the future if that is the type of role. I know that sometimes you do have to make hard choices and you do have to do things that people might find frustrating or, not in line with what they were hoping for. But, I think the more you can try to enlist the willingness of the people that you're working with, the smoother everything will go for everyone.
So definitely build an army of the willing. Okay, always good to know. That does kind of make me think about, I often talk about my career track being very odd and windy, and students will often ask, is there anything that you do non-science related that really did prepare you for your job? And I often say, like, theater actually turns out that those skills are really useful in what I do today. Is there, because you're talking a lot about like not just managing data, but like sort of navigating, complex human interactions. And I'm curious, is there anything that you do outside of science that maybe did help you kind of feel more confident or navigate that, or you just kind of like learning it on the fly?
That's a really interesting question. I am not sure. Um, I mean, certainly I feel like the communication skills I've built through teaching are something that influence my role as a collaborator. I feel like I have, through years of practice, hopefully learned to be a good listener and really try to understand where the people I'm interacting with are coming from, right? As a teacher, understanding, rather than assuming that students understand things in a certain way, really listening to the words they're saying as an insight into what their actual thought process is allows me to meet them where they are in a different way. But that's still kind of academic. Outside of that, I don't know. I mean, I guess I've been involved in team projects in various ways throughout my life. I did music for many years. I played trumpet in an orchestra all the way through
Oh, very
college. And
cool.
so that's something, I guess, that's another feeling of um and I guess
Collaboration.
in some ways you can see big parallels. I mean, if you're the first trumpet player in an orchestra, people are going to hear you, right? Like you're loud, but you're still the goal is still to be part of a collective experience and producing a piece of art that no one individual could do on their own. You have to do it together. So there's that. And I guess also my sport of choice all through college and my 20s was ultimate Frisbee. Um,
Oh,
and um, and that is a sport where it's there. One thing that's unique about it, so it's a team sport, but beyond that, it's also all self-refereed. So there are no officials on the field. Even at the highest level of competition, they only have something called observers. So everything is called like if there's a foul or if there's any controversial thing that happens on the field, it's up to the players to talk with one another and work out what they think happened. And then there are different consequences for whether they agree or disagree. But I think that it reflects my personality. And I feel like what I think again makes science work is if everyone is coming at it with the goal of not doing bad actions, right? So because it's self-refereed, you're never trying to get away with something, right? You're not trying to see, can I get this over on the ref so that they don't see what happens? My kids both play soccer, and I watch every game with like the feeling, oh, the ref missed that call or that call. The kids are like trying to get away with things, like, and not get called. And so I think this ethos in Ultimate of we're all in this as a collective, it's called spirit of the game. It's like this idea that we're not trying to cheat. Like the whole goal is that we're all out there just doing our best, and not trying to unfairly take advantage of anything. So in some ways, I feel like there are parallels to science, right? That the goal isn't to get a big paper because you cheated. Like that's not it. That's not going to be useful in any way, right? The goal is to really, be genuine and be a good actor all the time in the work that you're doing, because that's how we learn new truths about the world and, really move science forward. So I guess those are two things that we could pull on, that have influenced my work style as well to some extent.
I love that. I did not know that about Ultimate Frisbee, but now I'm fascinated.
That's part of why
And
it's like such a hippie sport, like the no reps thing. Like, what is that?
that's really cool. So thank you for that. That's very enlightening. And now I need to go figure out where I can go play Ultimate Frisbee because I feel like that really sounds like something I would enjoy as somebody who loves community. All right, moving back to sciencey things.
Yeah.
So you'd mentioned that you are wrapping up the study, and I just want to make sure I'm clear in my own head. If I understood correctly, this has kind of like multiple arms, though. So do you mean like you were like going to be at that final arm, or are you wrapping up like just one of the many arms? Just so I understand.
Yeah. So what's wrapping up right now is the clinical enrollment. Okay, so our last patients have been, I think as of now, contacted or enrolled, scheduled for surgery before the end of 2025. And so their first initial baseline appointments have been made. So once we hit the end of the year, there are going to be no more surgeries. So there's not going to be any more knee surgeries or thoracic surgeries for patients enrolled in the study. We're still going to be collecting data from those that were enrolled through at least the 6 months. Some of them even have 12-month follow-up data. But that means that our clinical side of the study is going to be winding down. So the collection on that side is winding down. In terms of the omics data so that means like the brain imaging samples those will be done being collected as well. Like, so as the clinical side of things stops, we won't be collecting new blood samples after the 3 months post-op visit for these patients. So we're really working on getting all of the tubes that we do have to San Diego, getting all of them onto the run lists for data generation. And honestly, the goal is that all of the ODGCs will have generated the data on everyone by the summer of 2026. So aiming for June or so of 2026 to have all of the omics data generated. But the analysis of the data will be ongoing then for at least another year. That it finally wraps up in July of 2027. The current funding for the DIRC. So we really, in terms of doing the analysis, the primary analysis for the study, developing the predictive biomarkers, getting the data all uploaded for both internal and external use. So yeah, just really all of the data processing stuff is, we've made progress already and it's been underway this whole time, but we have another year to wrap all that up before it all has to be complete. But yeah, so certain components of the project are wrapping up, but others are going to keep going for a little while longer.
Okay, thank you for that clarity. And so you said that some participants will be, so it's longitudinal in that they'll have the surgery and then there will be set follow-up. And you said, so there's 2 points, if I understand correctly?
For the blood sample collection, we collect at baseline prior to surgery, then at 6 weeks after surgery, and at 3 months after surgery. So those are the 3 different time points that we collect blood data.
Okay. And then out of curiosity, has there been any data releases yet, or is that still, you still very much doing analysis?
Yeah, so we have been doing interim data releases. We've had a data freeze every March for the last 2 years. So we've had internal release freeze 2.1 from was in June, and we're just preparing right now for internal release 3, which is going to come at the either right at the end of December or early January. And that's going to basically contain any data that we've generated so far on a set of subjects that were enrolled in the study prior to, I think, March of 2025. That's what's in Freeze 3. We also have released some data externally through the NDA repository. So it's, I can't remember, an NIMH data archive, I think, is the NDA. So we have some data already released there. That's also ongoing. The goal is to keep rolling out additional data releases for all of the data types through the NDA every 6 months or so. So as the data are being processed, we're also delivering it as it's going along. And to be clear, this is only the baseline data that we're releasing at this point because of the main goal of the study is to develop this predictive biomarker. We don't want to unblind or release any of the later data at this point because it could in some ways influence or bias the analysis that we're doing on the predictive side of things. So all of our predictive analyses are going to be done on the baseline data, and that's what we're then releasing for now. We're keeping the later data points, the data from later time points under wraps for now. Eventually, it will all be released at the end of the study, though.
Okay, gotcha. So what is kind of on the horizon then for A2CPS, and are there kind of phases beyond this current study as well?
That's a good question. We have started meeting as a group to brainstorm new directions that we can go in with the data. I think so. Again, for the A2CPS project itself, we still have a lot of work to do in terms of the predictive biomarker analysis. Like that really hasn't happened at all yet. I think we have some preliminary approaches and ideas around it, but we haven't answered the primary aims of the grant in terms of individual biomarkers and multifaceted biomarkers to predict chronic pain. So that is a big thing that we're going to be doing on the project right now. But yeah, we are also thinking about, what can be the next steps, leveraging this great community that we've developed through the project. Are there other questions that we can think to approach with this data? So that's something that we've started spending some time brainstorming about as well. Because I think that it would be, a shame if we just let this consortium fall apart at the end of it and didn't continue working together on some things, even outside of the initial aims of the grant.
Awesome. So it looks like you're at least kind of thinking about what that sustainability looks like. That's good to hear because it sounds like this is going to be a really impactful project.
Yeah.
And it sounds like you put a lot of work into building this community in the first place.
Yeah, for sure, for sure.
So if I'm a researcher and I'm interested in this program, like what's the best way for me to get involved or engaged?
Yeah, so I mean, I think the first thing to do is, to reach out to someone who's involved in the project right now. We're really going to still be the best resource for giving you information. We have a journal club today. So we do have community outreach related events that happen. And then, yeah, so we have a website where you can get information about the people involved in the project and who to contact if you have questions. And like I said, there was some data already available through the NDA. So that'd be another option is to go to the NDA and find the data that have been released for the project already, that's something that you can then take a look at. But I think really right now, the best bet is still to interact with someone who's been involved with the project already. Again, given its complex design, that it's probably helpful to have someone internal to help guide someone interested in the data or in the project through what's available and what the resources are.
Okay, thank you. So, as we wrap up, I had one sort of question that was more for my curiosity. So you said sort of, your background is definitely more in the maths and then statistics, and that the pain researchers is definitely a little bit more new for you. And I'm curious if there's something that really surprised you or something you wish people understood more about chronic pain research, being kind of like new to it yourself.
Yeah, I think that one of the things I feel I've learned from some of my colleagues and collaborators is that that I don't know, that pain, I mean, this is really like oversimplified, that pain is really complex, right? I think that I hadn't really thought about all of the different aspects of what can lead to someone experiencing pain are like, so that it can be things in their psychosocial state, that it could be things in their immune state. So it's like all the way from, yeah, it's all a whole range of different mental and physical aspects to someone's experience of pain. And I feel like, with any sort of not necessarily visible trait, as with any not necessarily visible trait, I think it's really hard to understand what someone's experience of pain is. And I think that's something that I've gotten a lot more sort of empathy and sympathy for through this project. That, it's something that affects a lot of people. And I think that there's not a one size fits all intervention that's going to help everyone. And I think that's one of the things that we're hoping on this project to do, is to understand how to help people who have all different reasons for experiencing the pain that they're experiencing. And hopefully with a study this size, we have the ability to do that kind of subgroup analysis to some extent, where we can sort of say, for the folks that are having a particular immune response, this is what we can do to help them. For the folks that it really is linked to social behavioral issues that they're experiencing, well, here are the types of interventions that might be useful. So I think that's been one of the things. It's been really fun for me to work on a phenotype where it is so close to a stage of intervention. So I think a lot of my work in the past has been on complex traits like cardiovascular disease, or asthma, or oral facial cleft disorders. And it feels harder to know. I think it's great to understand the biology behind those different traits. But I think with pain, it seems like it's that much closer to something we could actually recommend behavior changes or recommend treatment changes that are going to have an impact right now. And I really like that about working on this phenotype as well.
Yeah, that's interesting to kind of think about, the more holistic approach. And it sounds like that's exactly what this program's doing, which is great to hear. Well, thank you so much, Margaret, for, sharing your career path, for sharing a little bit more about ACE2PS, and for sharing about Ultimate Frisbee.
Oh, it's my pleasure. I'm really glad that we were able to have this conversation.
All right, thank you.
You have been listening to Decoding the Data Ecosystem, a CFDE Training Center podcast. Be sure to check out our other episodes in this series. Find out more information about CFDE data and tools that may be valuable to your research by visiting our website.